You don't need to put anything, I'm talking please. You don't need to put anything in your table of contents because yesterday I think we put applications and we put 118, 119. This one will go on 119. If you'll notice on the booklet on the front, today we're going to do the same thing we did yesterday, but we're only going to do problems that have 3 variables and 3 equations. You will do all of this on your calculator. What we're going to do, we're going to go completely through the first 2, calculator and everything. And then after that, I'm going to help you set them up. And then we'll see if you need us to go through the calculator together, or if you say, I know how to do the calculator part, I'm not worried about that part. I'm not going to pull up the notes because, as you know, we've had trouble. There's a gremlin living in the smartboard. So I'm just going to set them up here with, you can just read them off my notes here. Please notice on example 1 and example 2, it says use Kramer's rule. If you see the very last sentence in each of those first 2 examples, it says use Kramer's rule. We're not using Kramer's rule because you don't know Kramer's rule. We're just going to do them with inverses. So let's look at that first one. The perimeter of a triangle is 59 inches. First of all, do you remember what perimeter is?
Outside.
What about the outside? Yeah, you add up all the lengths of all the sides, right? The longest side is 11 inches longer than the medium side, and the medium side is 3 inches more than the shortest side. We're going to find the length of each of the 3 sides of the triangle. What are we looking for? What are we looking for? The length of what? That's right. Now listen, I'm telling you, you've got to do this. You're going to write X is the length of the longest side. But why do I have to do that? I know. Don't be stupid. The length of the longest side. We'll let Y, and you can do this. I don't mind if you do that. The length of the middle side. And Z is the length of the shortest side. You have to do that. Otherwise, it doesn't make what you're doing doesn't make any sense because you don't know what you're finding. All right, the perimeter is 59 inches. Can I write an equation right now, just knowing that the distance around that triangle is 59 inches? I'm listening. That's it. X plus Y plus Z equals 59. If you add up the lengths of all the sides, you get the distance around, which is 59. Now let's look at the next sentence. The longest side is 11 inches longer than the medium side. What does the word is mean in math? Equals. So when you are translating, remember we're translating one language to another, English to math. When you see is, it's equals. So it says the longest side. What's the longest side? Is 11 inches longer than the medium side. All right, 11 inches longer than the medium side. Y plus 11. The medium side, I guess I should have put medium instead of middle. The medium side is 3 inches more than the shortest side. The medium side, what's the medium side? Medium side is 3 more than the shortest side. 3 plus Z, or Z plus 3, it doesn't matter which way you write it. There's your system of equations, right there. Absolutely. Now, in order for us to put this in the calculator as a matrix, remember I've got to have the x, y's, and z's all on the same side of the equal sign. But they're not right now in two of those equations, are they? So, what do I do to this equation to make the x's and y's and z's all be on the left side? Subtract y. Good. So this is going to be x minus y equals 11. Where's the z? Please put a 0 in for the z. Now, you don't have to do it here if you don't want to, but make sure you do it on your matrix. You're going to put a 0 in for z. So let me just do it here just so you'll remember. What do we have to do here? Subtract z, so I'm going to have what? Where's my x? Good. Again, you don't have to write 0x in here, but if it makes you more comfortable, go ahead. So we've got our three equations. Now what I want you to write down is your matrix equation. So we're going to go right below that, and we're going to write our our matrices. What are the dimensions of the first matrix going to be that we write down? 3 by 3. A 3 by 3. Why is it going to be a 3 by 3? 3 equations and how many variables? 3 equations and 3 variables, that's right. So, let's write them down. I'm getting my book so I don't have to scroll up and down and back and forth. Okay, what's this first equation going to say? I mean, excuse me, this first row. Good. 1, 1, 0. 1, negative 1, 0. 1, negative 1, 0. And? Everybody good there? Good. Times x, y, z equals, right? What?
59, 11, and 3.
Now, here's what I would suggest you do. I would suggest that you call this one matrix A, and I would suggest that you call this one matrix B. Now, in order, hang on, don't go to your calculator quite yet. Just give me just a second. In order to get x, y, z by itself, what do we have to do? Good. We're going to find the inverse of matrix A and do what with it? Multiply it by matrix B. Good. So here's what you're going to do. You're going to do matrix A inverse times matrix B. So you go into your calculator and you find matrix A inverse and you write it down times your matrix B. I'll do it on mine. You do it on yours. Let's see if we can get the same thing. Oops. All right, so matrix A is 1, 1, 1, negative 1, 0, 0, 1, negative 1. Please, please, after you type in matrix A, make sure you type the darn thing in right, okay? Then I'm going to quit, and I'm going to go back in, and I'm going to edit matrix B. which is a 3 by 1, 59, 11, and 3. What do you need now? A inverse. So you're going to go to matrix. You're going to grab matrix A, inverse. Okay, that's not what I want to write down. Okay, so we're going to go math, fraction. So you're going to write that matrix. Did you all get that matrix? Okay, so you're going to write that matrix right here. Whoops. You're going to write that matrix right there. So what are you going to type in right now? Yep, by matrix B. 28, 17, and 14. So you're going to go down here and you're going to write x, y, z equals, what did we say, 20 what? 28? That's right. So you're going to write the longest side is, and don't just say 28. When you're given the unit, go ahead and use it. The medium side is 14 inches, 17 inches. The short side is 14 inches. You okay here? Setting it up. Here's what I want to know. I want a thumb on this one. Once we get, constant, once we get this piece done, once that's done, how easy is it for you after that? I want a thumb. So what we just need to practice is setting them up, eh? All right. So we will not take the time then to go ahead and solve the rest of them. We'll get them set up. Sound good? Okay. Let's go to example 2. The Arcadium Arcade in Lynchburg, Tennessee uses 3 different colored tokens for their game machines. For $20, you can purchase any of the following mixtures of tokens. You can get 14 gold, 20 silver, and 24 bronze. Or you can get 20 gold, 15 silver, and 19 bronze. Or you can get 30 gold, 5 silver, and 13 bronze. What is the monetary value of each token? What's the first thing I want you to do? Define X, Y, and Z. So what am I looking for? Am I looking for the number of them or the value of them? The value, right. So you're going to do this. X is the value of a what? Of a gold token. What do you want to let Y equal? Value of a silver token. Look, you can do this. I'm fine with that. If you want to do that, if you want to write it out, that's fine. Z, good, is the value of a bronze token. Here we go. For $20, you can purchase 14 golds, 20 silvers, and 24 bronze. It's $20. Now let me ask you a question. Yes, yes. So Sarah said, does every one of these equations equal 20? Yes. What if a gold token costs $2 and you buy 5 of them? That's $10. What if a gold token costs is worth $3 and you buy 2 of them? 6. What if a gold token costs X bucks and you buy 3 of them? 3x. So that first set, it says 14 gold, 20 silver, and 24 bronze. There you go. There you go. There you go. Now, do you see behind the first or in capital letters? 20x. And that combination also is worth $20. You have one more combination. You have 30 gold, 5 silver, 15 bronze, 13 bronze. So what equation could we come up with there? 30x and there's your system of equations. Do you have to do any manipulating of these equations before you can put them in your calculator? No. Why? Good, because the x, y, and z's are already on the same side of the equal sign and the constants are already on the other side. Okay. You told me that that's the only part you wanted help with, correct? Move on to example 3. You can go back and you can finish those if you decide you want to. Movie tickets. Last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. The proceeds, that means how much they took in, was $64,600. Tickets can be bought in one of 3 ways. You can buy a matinee admission that costs $5. You can buy a student admission that is $6 all day. And you can buy regular admission $8.50. Oh, what's it ask? How many of each type of ticket was sold? If twice as many student tickets were sold as manatee tickets. Matinee tickets. Matinee tickets. That's not spelled right. All right. What the devil are we looking for? How many of each type of ticket? What are the types of tickets we can buy? All right. Let's see. Manatee tickets. So X. Now, is it the number of tickets of each type or is it the value of each ticket? Read the question. How many of each type of ticket? Okay. So X is the number of what? Manatee tickets, the number of matinee tickets. Is that how you spell matinee? That doesn't look right. Yeah, no, I said manatee. That's, yeah. Is that how you spell matinee? That just doesn't look right. Okay, tickets. I'm going to have to look it up because that bothers me. Yeah, I'm going to look that up. Y is the number of student tickets. Okay, number of student tickets. And Z is the number of regular tickets. Let's read the question, shall we? Let's go from the beginning. Last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Stop. Can we write an equation? Because we know that 8,500 tickets were sold. X, Y, Z? Add them together. Yeah, add them together. X plus Y plus Z. Equals what? Proceeds, that means how much money they took in, totaled $64,600. So is that X plus Y plus Z equals 64,000? No? What do I have to do? 5X? What's 5X? 5 is the $5 is the cost of a matinee ticket, and we're selling X of them. 5X plus 6Y plus 650Z. 850? Okay, 850. Equals what? 64,600. I need another equation. Go to the twice as many piece. You see it says how many of each type of ticket was sold if twice as many student tickets were sold as matinee tickets. Now I'm going to ask you a question. So was it matinee? Is it student tickets equals twice the matinee tickets, or is it the matinee tickets is twice the student tickets? Twice as many student tickets were sold as matinee tickets. You think? Okay, I'm gonna make sure that we all understand this, because I get this backwards sometimes. I'm not gonna lie. Which was sold more of, student or matinee? Student. So if they sold 10 matinee tickets, then they sold 20 student tickets. Is that right? Twice as many student tickets were sold. And matinee is X, student is Y. Which one of those equations can I put 10 in for X and 20 in for Y, and it's a correct equation? If I put these two numbers into this first or this second equation, that would say 10 equals 2 times 20. First one, isn't it? 20 equals 2 times 10. Yeah. So it is, yeah. How many of you would have gotten that backwards? Yeah. I might have too. That's why I always put some numbers in, and then I decide which of those equations it works in. Does that make sense? So Y equals 2X. Well, what about it? The Z is going to be 0. So do I have to manipulate any of those equations? Okay, how are we going to manipulate this one to get it in the calculator? I need the X's and Y's and Z's all on the same side of the equal sign. Do what? No. What if I subtract 2X? Wouldn't that say negative 2X plus Y equals 0? Look, what if I had divided by 2? I'd have had Y divided by 2 equals X. I got to get this whole confound thing over there. So I subtract 2X from both sides. Now, question, could I have subtracted Y from both sides and made it say 2X minus Y equals 0? Of course. Same thing. Wouldn't matter.
Still have the 0Z, right?
I still will have a 0Z. So I still will have a 0Z. And if you want to put it in there, that's fine. If you don't, you make sure you put a 0 in your matrix when you put it in your calculator. Your matrix would be 1, 1, 1, 5, 6, 8.5, or 8.50. Say again? Negative 2, 1, 0. That would be your main matrix, yes. Any questions there? All right. Let's go on to example 4. I'm not going to lie to you. The money ones typically are the ones that give people more trouble. So just be careful. Let's look at example 4. Tracy wants to buy pie. So like Joan has been buying pie. Tracy wants to buy some pies for her sister. She has a budget of $82 to spend on $5 apple pies, $4.50 banana pies, and $5.50 chocolate pies. She wants to buy 16 pies for her sisters. And she must buy as many chocolate pies as apple pies and banana pies combined. Question right there. Which is the most popular pie for her family? Chocolate. She's going to buy as many chocolates as she does the other two combined. How many of each item should she buy? What are we looking for?
The amount of pies.
The number of pies. Correct. So let's let X equal the number of apple. Fine. Y is the number of chocolate. Was it chocolate? Banana? If we go in order, we'll say banana. I've never had a banana pie. Anybody had a banana pie?
But there's wafers in it.
Like a banana pudding? All righty. Shh. Here we go. Here we go. We're going to start at the top. She wants to buy pies for her sisters. She has $82 to spend on apple pies that cost $5, banana pies that cost $4.50, chocolate pies that cost $5.50. Stop. Can we write an equation? We can write an equation for the. Have you got it already? I know Levi's doing guess and check back there, and I can see by the look on his face when he has it right. All right. What's the value of X apple pies? Each one costs $5, so 5X. $4.50 for each banana pie. And $5.50 for each chocolate pie. That totals $82. She wants to buy 16 pies. Stop. She wants to buy 16 pies. X plus Y plus Z equals 16. There you go. All right. Because I got 3 variables, I got to have one more equation. It says she wants to buy as many chocolate pies as apple pies and banana pies combined. Okay, let's look at this. Let's make up a number. Let's make up some numbers. Let's see. She wants to buy as many chocolate pies as apple pies and banana pies combined. So the number of if she buys 5 apple pies, and 3 banana pies, how many chocolate pies does she have to buy? Because she wants to buy as many chocolate pies as apple pies and banana pies combined. Like that, right? So how are we going to do that? Z equals X plus Y. There you go. Guys, I am not going to lie to you. I've been doing these kind of problems for a long time. And I still, for that kind of an equation, I'm just going to tell you, I will go and make up some numbers and then make the equation work with those numbers. Okay? I still do that. So don't sweat if you think, oh, I know how to do that in my head. Don't worry about it. You have two different ways you could rewrite that equation. I could subtract z from both sides. And that would be x plus y minus z equals 0. Or, what could I do? Minus x and minus y. So I could do subtract x and subtract y. Move them over there with the z. Either one of those is fine. Doesn't matter. Questions about how we got that one set up? Okay, let's talk through your 3 by 3 matrix. What's going to be in the first row of your 3 by 3 matrix? 5, 450, 550. Row 2, 1, 1, 1. Row 3, let's use this one. 1, 1, negative 1. What will be in your 3 by 1?
82, 16, 0.
Good. 82, 16, 0. Well done. Well done. Okay, we have 2 more to set up. You're going to have at least half an hour to work. Well, what, 10 till? Yeah. Huh? What? Yeah. Well,
No, we're good.
no, we're going to, I think, I don't, I think I don't have a problem not doing example 5, but we're going to do example 6. Oh, we're going to do example 6. Yes, absolutely. Absolutely. Well, so let's look at it. So what Trin said was, don't you change those percents to a decimal? Bet your boots you do. Okay, so let's read. Bet my boots. They're getting old anyway. No. Marina has $24,500 to invest. She divides the money into 3 different accounts. At the end of the year, she had made $1,300 in interest. Do you guys know what interest is? Okay. The annual yield, that's the percentage that she earns, on each of the 3 accounts was 4%, 5.5%, and 6%. If the amount of money in the 4% account was 4 times the amount of money in the 5.5% account, how much money did she put in each account? How many things am I looking for? 3. And what are they? What am I looking for? The money, yeah, so we'll say X is the amount of money in the 4% account. We're going to let Y equal the amount of money in the 5.5% account. And we'll let Z equal the amount of money in, was it 6%? Yeah. Okay. Here we go. She's got $24,500 to invest in these accounts. Stop. Say again. What do you mean all of them are going to equal? So, no, not all of them are going to equal 24,500. Not all of them, just one. You mean multiply x times y times z? That's right. Okay, okay. So the amount of money in the first account plus the amount of money in the second account plus the amount of money in the third account is the total amount of money she had to put in the accounts. Now, we're going to the next piece where it says at the end of the year she had made $1,300 in interest. So I'm going to have something equals $1,300. Do you agree? You've got the right idea on the 4x, but because that's percent, 0.04, right. So she's going to earn 4% on all the money she's got in this first account. So that's 0.04x plus 0.055y plus 0.06z. And that's the amount of interest that she earned. That's going to be the hardest equation for you to set up. For some reason, students have trouble with that one.
So then we just have to do that 4 times.
Okay, now let's look at the last thing. It says if the amount of money in the 4% account was 4 times the amount of money in the 5.5% account. Is that going to be x equals 4y, or is it going to be y equals 4x? Because I'm going to get them backwards. Why do you say y equals 4x? The amount in the 4% account is 4 times the amount in the 5% account, 5.5%. What if we put $10 in the 5.5% account? Then how much would be in the 4% account? $40 would be in the 4% account, right? 4, that's the x. 5.5% is the y. Which one of those? X equals 4y. X equals 4y. I'm telling you, I'll get them backwards if I don't do this, and some of you will too. Okay. X equals 4y. I hear a big sigh. Do we need to manipulate any of those equations before we put it in our matrix? The last one, how do you want to manipulate it? Great. So if we subtract 4y equals 0, what's the z value in this last equation? Z is 0. Gosh, you're doing great. You're really, I mean, from what I'm hearing, you're doing real good. Now, you are going to show your work exactly the same way you showed your work yesterday. Did we do all this on the same page, or we went separate pages? Okay, so here's what you're going to do. Is that the second one we did, or was that the first one? That was the first one. You're going to write down your system, okay? Excuse me. Start here. You're going to write down the system of equations. You're going to write down your matrix stuff. You're going to call the first matrix A. You're going to call this matrix B. You're going to write down, this is your A inverse. And then you're going to write down the answer and your sentence. Do you know what you need to write down?
Yep.
Because I'm going to be a cranky old lady when I grade these, because I want you to show all the steps. But use your calculator to get the answers, okay?